Let's discuss the question number 46 from TS6, and the topic is strength of materials. So a column is given basically, and an eccentric load is applied which is at a distance E from the axis, and the cross section details are given as it's a square cross section 40 by 40 mm by 40 mm. Okay, so this is how it is, and what is asked is the stress developed along HCD, stress along CD is 1.2 Newton per mm square. So obviously this will be compressive. And what is the stress along AB? That is what is asked. Okay, and the load value is given as 1600 newtons. Okay, so when the load is applied, an eccentric loading is applied at P, this is equivalent of applying, if you look at the center, this is equivalent of applying P and the moment M, which is PE. So on the cross section you have the compressive load P. At this point you have the compressive load P plus you have the bending moment MP, which is along this axis. Okay, so now the compressive stress because of the load, the normal load, is P by A, which is P by A, and A we know that it is B square. Let B with the width of the cross section, and because it's a square cross section, so it is B square. So now the bending stress because of the bending load will be M by I into Y. This is from bending equation. So now because it is bending like this, okay, so this is my neutral axis. So let me just draw it here. This is my neutral axis and this is my Y, and the I will be basically the moment of inertia about this neutral axis, which is BH cube by 12 into bending moment into Y is this distance, which is B by 2. Now H is also B here, so this is M by B power 4 by 12 into B by 12, so it will be M by B cube 6M by B cube. Okay, so now at HCD the effect will be, you have the compressive stress and the bending moment also will give, this fiber will be also in compression because of the bending moment. So it will be sigma C plus sigma B will be the stress there. So it will be P by A plus 6M by B cube, so which is nothing but P by B square plus 6M. M is nothing but P into E by B cube. So if I take P by B square common, I'll be getting 1 plus 6PE by P is common, so 6E by P. Okay, now let's substitute the values. Basically I don't know E value, rest of the things I know. So this value is given as 1.2 compressive, P by V square, P is given as 1600 and P is my 40 mm, so 40 whole square plus 1 by 6E by 20, 6E by 40. Yeah, because I have taken out B common, so the B is 40, so this will be 6E by 40. Okay, so basically I'll be getting 6E by 40 value to be 0.2. Okay, so now at the edge AB you have the compressive stress which will be always there, but the bending moment will produce a tensile stress here and this fiber, so that will be sigma P. So this net is the compressive, so sigma C is again P by P square minus 6PE by B cube. So this will be P by V square 1 minus 6E by B. so which we already got as 0.2. So P is again 1600. P is again 1600 by B is again your 40 whole square, that is 16 by 1 minus this entire value I can substitute as 0.2. So this will give rise to 0.8 Newton per mm square. Remember, this is compressive because the sigma C is positive and sigma B is negative. So what is the stress is 0.8 and it is compressive, so the minus will come. Okay, so the answer is D. Thank you.